Let us compile the numbers studied so far. These are called rational numbers, this whole number, fractions, this integer, these two terminating decimals, and this one recurring decimals all comes under the category of rational numbers. And if we have to bound rational numbers by the definition provided is any number which can be expressed in P upon Q form where P and Q are integers. Why this definition has been framed? Just to distinguish rational numbers from the irrational numbers. Okay, if you see here, all of these numbers can be expressed in P upon Q form. This is here P upon Q form. Okay, so by writing 1 in the denominator, the identity of this number has not been changed. It is still 2. This is already in P upon Q form. This is also in P upon Q form. Further, you can change it into improper fraction. This is minus 512 and it still remained minus 512. This is 4.2, which can be expressed as 42 over 10. Similarly, this terminating decimal can also be expressed in P upon Q form, and we also have a technique to convert this into fraction. No, so the vulgar fraction for this is this. We have learnt about it. You can now convert this into improper fraction. So any number, any number which can be expressed in P upon Q form will be called rational if P and Q are integers, because otherwise we can convert this also into an P upon Q form. So this is convertible in P upon Q form, but P and Q are not integers here. Okay, in all the above cases, this is an integer, positive integer, this is integer, this is integer, this is a negative integer, this is a positive integer, positive integer, positive. So all P upon Q are integers here, but here Q is integer but P is not an integer, so this does not fit into the definition of this, and that's why purposely this line has been added to the definition of rational numbers. So rational numbers are the numbers which can be expressed in P upon Q form where P and Q are integers. Now here these all are irrational. Non-perfect square, 7 is non-perfect square, 27 is non-perfect square, 16 is non-perfect cube, 15 is also, and here also what do we have? We have a decimal number whose digits are not terminating, in fact not recurring. If you see the pattern here, it's 3737737777. So nothing is you cannot say something is recurring. We cannot write this in this form. Where will you put the bar? Okay, so this is also an irrational number. In fact 3.570577700, and then means in the similar way you may write anything. So this is also an irrational number. Okay, so this is just a way to write down irrational in decimal forms. Now this is irrational, this is rational, and they are collectively called real numbers. Why this name has been given them? Okay, so the thing is, so the answer for this question is based on the next number family. Means after irrationals, is there any number that is there any number left which we have not studied so far? Okay, so yes, there are numbers and we will be studying them in the senior classes. Let me tell you what is that. If at any point you get x square equals -1, right now there's no chance. Till class 9 maths there's no chance, but in senior classes you do get the situations where x square is -1 or x square is -16. Okay, or whatever, x square is -15. Okay, so what are these numbers? So if this is this, so what is x? X is root of -1, and x is root of -16, and x is root of -15. So do you think this number exists? Square root of -1, is there any number like this? Where will it be on number line? Square root of -16. And square root of minus 15, if you are thinking, yes ma'am, this exists, it is minus 4, so it's wrong, because if x is equals to minus 4, then x square is gonna be positive 16. So square of any number, whether it is positive or negative, it can never be minus 1, it can never be minus 16, it can never be minus 15. Okay, so if you're going to encounter such numbers, so till now we cannot digest them. Okay, but if they do exist, we'll call them imaginary numbers, because they cannot be real, because square of anything cannot be minus 1. So they are listed under the new category, which is called imaginary numbers. So whenever we have to study a new number family, we combine the older one, no? So that's why when we encountered these numbers, the new numbers in class 9, so we bounded the previous one by the name rational numbers. Okay, and we called the new one as irrational. So now we are aware of this. So when we will encounter these numbers, okay, so it's gonna be a new number family. Okay, and they are means these numbers don't seem to be real, so they'll be listed under the category in imaginary numbers, and the previous number families will be bounded under the name real numbers. So this is a real number, this is a real number, this is a real number, these all are real numbers. Okay, and we do have a way um, um, to locate them on real number line. No, we can locate all these numbers on real number line. Okay, so when you can locate those numbers, when you can position those numbers, that means those are real, because you can find out their length. And actually means if your number line is 1 unit, you can find out how many units is root 15. Okay, so when you can actually position them, that means they are real numbers. And imaginary numbers, we don't know what are those numbers, where do they lie, that's why they have been named as imaginary numbers. Okay, and if I tell you this small flow chart, so I would say we have real numbers, we have imaginary numbers. Okay, under real numbers, what do we have? Rationals and irrationals. So there are two, you can say there are two number families under it, and within this we have furthermore, let's not write them, you're aware of them. And this comes under, there is another name for this, it's called complex numbers, combined name. Just like real numbers was a combined name for rational and irrational, we have a name complex numbers for these. So this is your this is what you are going to study in senior classes. Right now your class 9 syllabus is just limited to real numbers. Okay, so let's end the video here.